what we did on last week before we went away for Thanksgiving is we started talking about how do you know if there's an association between two quantitative variables. And the best way to do that is to make a scatter plot, all right, which is what we did right here. So we went through, we guessed what how old these different celebrities were, and then we compared it to the actual, and we plotted those points. So that's these points right here. And then the question was, is your guess, we see it says EV, that's the explanatory or the predictor. Is your guess a good predictor of what the actual age was? Okay, and if you look at this, most of the dots that we did are fairly close to this blue line. This blue line would be if you were a perfect guesser. So we had some guesses that were perfect. One right there, another one right there, another one right there. But the rest of them are pretty close. So you guys are pretty good guessers of someone's age by looking at a picture of them. Okay, when you describe a scatter plot, we use these four things. The direction, okay, so a direction can either be positive or negative. Okay, that's this right here that we talked about. Positive or negative meant the trend was going downhill. Positive, the trend was going uphill. Okay, the form was, most of the time it's going to be linear, or in some cases it's going to be nonlinear. So if you look at these examples up here, they kind of follow a line. They kind of are grouped around a line. So we'd say that those are linear. Okay. The overall pattern follows a straight line. If the overall pattern follows a curve, then we say it's nonlinear. Okay, so other nonlinear forms, sometimes they look like this. You know, you'll have a curve that goes like that, or you'll have a curve that goes like this. Those would be nonlinear. So if the dots were around something like that, we'd say that's nonlinear. Dots were around a curve like this, we'd say it's nonlinear. Okay, all right. Then the strength was, we had weak, moderate, or like medium, and strong. And that was how close the dots are to the form. So in this case, like here, a strong association would be the dots are pretty close to whatever the form is. The form in this case is linear. And the dots are fairly close to that line. So we'd say there's a strong association between the two variables. Okay, the farther the dots are from the line, the weaker the association gets. So these on the other side, these would be weak associations because the dots deviate quite a bit from the line. And then an outlier, that's nothing new. That's something that's way far off from the line. All right. So what we're going to look at here is we're going to take a look at the relationship between sugar and calories. We're going to make a scatter plot, and then we're going to describe it. So we're going to, first of all, we're going to describe the direction. We're going to describe if the form is linear or nonlinear. So remember, your choices here are positive or negative. Your form is either linear or nonlinear. These are your choices. So these are the notes from last Monday. Does anybody need a copy? You didn't have it? It says 3-2 on the front. It's got the actors and their names. You do, they're in the basket by the sanitizer. Okay, the strength is either weak, moderate, or medium, or strong. And then once we plot it, outlier. Whoa, what the heck is that? All right, so it's asking, is there a relationship between sugar and calories? All right, so we've got to decide between which one would be the predictor and which one would be the response. Now, sometimes it doesn't matter. You can do it either way. All right. So in this case, we want to know is if you know how you turn the candy over and it tells you how many sugar, okay, is that a good predictor for the amount of calories? So we're going to say that sugar is our explainer variable, and the calories is our response. So what that means is the explainer goes on the x-axis when we graph this, and the response goes on the y-axis. So this is going to end up on the x, and this is going to be on the y. Okay, another name for the explainer, it's also called the independent variable. And the response variable is often called the dependent variable. Okay, so just common sense would tell us, do you think this is a positive or a negative relationship? Positive would be as the amount of sugar goes up, the number of calories goes up. Negative would be the amount of sugar goes up, the calories goes down. Okay, so Mr. Murray, what do you think? Positive or negative? If you were to predict, probably positive. Okay, so our prediction right here would probably be that this is going to be a positive relationship. Okay, and what that means is as sugar increases, calories increase. That's what positive means. So we're going to predict that this should be a positive relationship. Now the form we don't know until we graph it. Okay, what do you think the strength is going to be? You think there's a strong relationship between sugar and calories, a moderate, or a weak? Okay, Mr. Sanchez. Probably, yeah, I would think strong. Okay, so let's see what happens here. Okay, most of us, we think, well, a lot of sugar, a lot of calories. All right, so what we're going to do now is take this information and put it into our stablet. Okay, so we got this guy open. Okay, so my explainer video is sugar, variable sugar. So I'll put sugar in grams. Response is calories. All right, and now you just go down the list and you type in the values. You can either leave spaces between the numbers or commas. So I'm going to do commas. Okay, so we added our data. Okay, we plotted it, and then we said draw the, find the, what was it? Correlation coefficient right there, and then draw the line. Okay, and the closer the dots are to the line, the better the fit. Okay, so when you look at this chart right here that says residuals, what that's doing is it's telling you how far from this line these points are. Okay, so if I took this point, this 44,370, everybody look up front, please. So if I took this point and I measured the distance to this line, okay, straight to that line, perpendicular to it, that would represent how far it is from that line. So that has a residual of negative 54. That means that this distance right here is 54, what I'm drawing. Okay, that's what that residual is. All right, so let's just sketch that line in on our notes. Okay, so let's see, draw a line. And let's kind of estimate it. It's a little bit above 400. And it kind of goes through these points. So something like that. Okay, so now what that does is that allows you to answer the rest of these questions here. Can we take this, Control C, sketch that, plot that right here. Okay, that was the actual one. So you can compare the two. All right. So when we look at it, we could say, well, what's the form? Well, to me, it looks linear in general. Okay, what's the association or what's the strength? Okay, now what this does right here, guys, this tells you the strength. So the closer that number is to either 1 or -1, the stronger the relationship. So that's only about halfway. If R was 0, that would mean really weak. If R was 1, that would be really strong. So if something's at 0.6, it's really moderate, which was kind of surprising. I thought it would be strong. Okay, now the whole point of this is, this tells you right here that sugar, the amount of sugar is a moderate predictor, not very good predictor, which I thought it would be strong. I was kind of surprised, is a moderate predictor for calories. So it's not just sugar. All right, and then we kind of identified that we did have an outlier. It was probably the peanut M&Ms. That one's way far from the line. Peanut M&Ms. Okay, now, we briefly talked about this idea between if something's got a strong or a moderate connection, that we say that has a relationship or it has an association. That doesn't necessarily mean it causes the other variable. Okay, so remember the other day I showed you, like when ice cream sales went up, shark attacks went up. So you can't say that or ice cream sales cause shark attacks just because there's a strong relationship between the two. So we talk a lot about that in the next section. All right, so let's take a look at this last one here. Okay, it's asking us to figure out if the amount of screen time is a good predictor of how popular different Star Wars characters are. All right, so like Darth Vader's got 150 minutes screen time in the different Star Wars movies. He's the most popular character. All right, whereas Boba Fett had 59 minutes. He's the least popular. Okay, so this one's asking, is the number of minutes of screen time a good predictor? That tells you that screen time is the explainer. So that's going to go on the x-axis. And the rank is now the response, and it's going to go on the y-axis. Okay. So the predictor that we're looking at is screen time. And the response is popularity. It's rank. Okay. And then we're going to describe these. Okay, so we got either positive or negative. We got linear or nonlinear. Weak, moderate, strong. Okay. All right, so let's see if is the amount of minutes they are on the screen a good predictor of how popular they are. Okay, that's what this is asking. All right, so we go ahead and we type that in and do our scatter plot. So let's do that. Take pause for a second. Do that. So, let's see. So this is screen time in minutes, and this is rank. Okay, and now we type in those numbers. Okay, so there we go. We got them typed in, and now let's take a look. Let's see what we get. Okay, there's our scatter plot. Correlation, negative 0.3. So we got a negative, and 0.3 would be weak. And there's our line. So it's weak because if you look at the residual graph, the distance that these are from this diagonal line are far. Okay, the dots aren't close to this horizontal line. You got them spread all around it, but not real close. So what this is telling you is screen time is not necessarily a good predictor of how popular the character is. All right, so copy this and then describe it. Draw our line. Here. sort of like that. It's just a sketch right now. And we knew that R was negative 0.38. And that tells you weak. Okay, so we got a negative direction. God, it's kind of hard to tell. I'd say sort of linear. Definitely weak. And it's hard to say outliers because this is not a very strong relationship, but possibly these might be possible outliers. Okay, so we had the one outlier was 150. Who was 150? Darth Vader. And the other one looked like to be 261. 261 was Han Solo. Huh. Yeah. But since the relationship is so weak, it's hard to say that those are outliers. That's why I just wrote kind of possible. So our conclusion on this would be screen time is not a good, is a weak predictor. Okay. All right, guys, that took just longer than I thought. All right. So we'll start with the notes for tomorrow. Tomorrow we go in depth at looking at this correlation coefficient. Okay, that's it for